Alright guys, let's do a video over the area of composite figures so that we can remember how to do those. Okay, at the top of your page is a couple of things we need to fill out. It says a composite figure is made up of two or more geometric figures. So when we mean geometric figures, we mean rectangles, triangles, circles, general figures that come off of our formula chart. So there's a couple of steps that we need to follow. Step one is to break the figure into geometric figures. After that, we need to write the formulas for each of those shapes that we have. Step three is going to be to find the area of all of these. And then step four is going to be to add or possibly subtract if you have to take out a shape, which we'll have an example of that, is to add or subtract the areas for the final answer. So we have to find, we add or subtract all the pieces that need to go together, or if some of them need to leave for the final composite area. So let's look at this first example that we have right here. If you look at it, obviously it's got some measurements on it, but it doesn't have an identifiable shape. So what we can do is we can break the figure up into shapes that we know. If we draw a line, right here we've got a square and then we've got a triangle. So that was step one. Step two is going to be to write the formulas. So for the square, we can either do side squared or technically that can be length times width. They're just going to happen to be the same number this time. For the triangle, let me switch colors here. It's going to be 1/2 base times height to find the area there. So let's go back to the square real quick. We have a dimension right here that's 8 and a dimension here. So 8 times 8 is going to be 64. And then for the triangle, we have to do base times height. Our base here is 5. And then our height here is not just this piece right here, but it's also this part of the red line that I drew. It's not marked over here, but this length down here is going to be the same as the measurement up here. So that's going to be 8 plus the other 4. So I'm going to do 1/2. Base was 5. Height was 12. So I'm going to solve this real quick. I can do the whole numbers. Multiplying that in my head is 60. And then half of that is going to equal 30. So now that I've got a measurement here that I've solved and a measurement here, we're going to put those two together because this is one giant figure where none of the pieces are being taken away. So 64 and 30 is 94. So our answer here is going to be 94. Our dimension is centimeters, and since this is area, we're going to use the exponent of 2. So 94 centimeters squared is going to be our final answer for this composite figure. Let's go through and let's do another quick example. We've got a shape here. It almost seems to look like a square, except for we've got 19 and we've got 18, so we know it's a rectangle basically, but it's real close to a square. And then if we want to, we can just draw or break up the shape in a different way. So I'm going to try a different method here. If you wanted to, we could extend this out into a normal rectangle and then end up taking out this piece here in a little bit. So let's just try to solve this a different way just to kind of help us out. So technically we didn't break the shape up into different figures, but we're going to take out a piece. In that step 4 we talked about adding and subtracting, so this is kind of along the same same idea. So to find the area, we would do length times width, and then we're going to subtract out. So I'm going to write a little minus sign here to remind myself that we're going to take out the triangle, which is 1/2 base times height. So it's kind of like getting a pair of scissors and snipping off this corner. So first I'm going to do the length times width. So I'm going to go to the side and do 19 times 18. So a total area for this whole thing is going to be 342. So now we just have to think about taking out this piece down here. So I'm going to switch colors for just a second. We need the base and the height. The base here, this piece is not marked for us, but if we know the whole length is 19, and we know from the corner to the edge where I started drawing my line was 11, then the difference there is 8. And then we're going to do the same thing here. We've got a whole length, or a whole width, I guess, of 18. We know from the corner to that edge is 12, so that means that the remaining piece is 6 there. So we're going to do 1/2 times 8 times 6, and then I'm going to multiply the whole numbers. So 8 times 6 is 48, and then after that, 1/2 of 48 is 24. So now I'm going to take these two dimensions and I'm going to subtract out this piece of a triangle that I had drawn in there to make a full rectangle. So I'm going to take 342 and I'm going to subtract out 24. And I get 318. So the dimensions here are millimeters, and then our exponent of a 2, because this is area. So this is another way that we can find composite figures. We just take the piece and make it into a shape we know, and then take out the chunk that we didn't need. So let's go to another example. We've got this one that's a shaded shape, and then we've got a hole cut out in the center, so we know that this is going to end up being subtracted out here in a minute. So we're going to go through the first step of identifying all the pieces that make up this composite figure. So I'm going to adjust the line real quick. Okay, so we've got a triangle over here. It's the same triangle that's over here, so if I find the area of one, I can just double them up, and then there in the center is a rectangle. And then, excuse me, we also have the circle there that will be taken out here in just a minute. So I'm going to go through and write my formulas. The rectangle is length times width. The circle is pi times radius squared. Then the triangle over here is 1/2 base times height, and that's also the same thing over here. So let's go through and let's figure out all of our dimensions. Going back to this rectangle, 12 is my length, and then my width is listed over here on the side, which is actually out here on the edge. If it's the same distance from here to here, it's the same distance on the inside. So that's going to be times 10. So I can easily multiply that in my head. That piece is 120. Let's go to the circle real quick. We've got pi times radius squared. pi we know is the value of 3.14. Radius, we know the whole diameter because from here to here is marked out to the side for us. So if the diameter is 5, that means that the radius is 2.5, and that's going to be squared. And then, so we'll go through and do that real quick. I'm going to do the exponent first, 2.5 times 2.5. This isn't technically 625. We had 2 decimal places, so I'm going to move over twice, and I get 6.25. So I've got the value of pi times 6.25. Oops, put that in the wrong spot. 6.25, so we're going to multiply that real quick. I'm just going to erase this line right here so that I can keep multiplying down at the bottom. Oops, that's a multiplication sign. Going to remember to put 2 zeros down here when I go to multiply by the 3. I had 1, 2, 3, 4 decimals when I started multiplying. So I've got 19.625, which is going to be my value right in here. I'm going to erase my little subtraction sign because I kind of made that pretty large. I'm going to write that value in there, 19.625. We know that this is eventually going to be subtracted out, but we'll get to that in just a minute. Now let's work on the triangles. The base of the triangle is still the length of the rectangle, so that was 10. So I got 1/2 times 10, and then my height here is 4. Now, technically, since I've got this triangle over here and I've got this one, if I were to half both of those values, if I did 1/2 times 40, I'd get to 20, and then I'd just double it right back up because I've got the other one over here. So 20 and 20 still make 40. So basically at this point, the half isn't needed because half of a triangle, or half of the formula here, the other half's over here. So we're just going to leave that at 40 for both of them. So I'm going to write it over here, and remember that that also works for this piece. So now we're to our final step where we're adding and subtracting everything together to get the area of our composite figure. So I'm going to add up the 2 pieces, or the 3, sorry, the 3 pieces that I need, the 2 triangles and the rectangle there. So 120 plus 40 is 160. And then I'm going to subtract out, do that in the final last color, I'm going to take 160 and I'm going to subtract out the 19.625 of our circle to get our final area of this composite figure. So I've got to borrow all the way over to the end. And I get a final answer of 140.375. Our dimensions here were feet. Again, it's still area, so I'm going to use that exponent of 2 for composite, or for the area of this composite figure. So that's just kind of a little example, 3 different examples of how to kind of deal with area of composite figures. Make sure that you have all of that ready for the next time you're going to need it in class for your teacher. Have a good night.